There has been a growing interest in studying and implementing innovative approaches in undergraduate math education, such as inquiry-based mathematics, where students learn through engaging in the practices of professional mathematicians. In particular, programming can support this inquiry-based approach by allowing students to engage in these practices as a tool for carrying out mathematical investigations. But as Lockwood and Morgan recently acknowledged, there is little such research on incorporating programming into undergraduate mathematics.
Our research is based in the context of the MICA courses here at Brock. MICA stands for Math Integrated with Computers and Applications and is a sequence of 3 courses over which students engage in these programming-based math inquiry projects. There is MICA 1 and MICA 2, which are first and second year courses, but in third year there is MICA 3, which is predominantly math and stats students, and MICA 3 Star, which is specific for pre-service mathematics teachers.
In an extended 5-year research study, the research team, which you can see here, has used the opportunity provided by the MICA courses to collect data without teaching interventions from the researchers. They examined the teaching and learning of using programming for engaging in pure or applied mathematical inquiry.
Using the instrumental approach as the main theoretical framework, the team aims to understand how university students learn to use programming as a meaningful tool for mathematics as mathematicians do, as well as how instructors and universities can support their learning. This poster aims at contributing to the research on learning. More precisely, we investigated what students are most proud of after working on projects of this nature and why.
As part of the larger research study, students in the MICA courses were invited to complete an online questionnaire at the end of their course to reflect on their experiences. 2 of these questions being, the things that I learned in the MICA courses that I'm most proud of is, and because, the responses being what we focus on this poster. For the qualitative data analysis, Jessica and I conducted an emerging theme analysis. We initially coded the responses individually, then collaborated to discuss and come to an agreement on the final codes for each response. The responses were then grouped into themes, and the themes were therefore grouped into categories. We also created different graphical representations of the frequency distribution of the results useful for interpretation.
When looking at the what, 10 themes emerged, which were grouped into 4 categories: programming experience, math experience, socio-emotional learning skills, and success in the course. The category most represented by students in all 3 courses is programming experience, meaning that students are most proud of their ability to program and their experiences related to programming in the courses. Something that could account for this is that students had a different experience in these courses compared to other math courses which they have been taking. No other math course at Brock teaches or integrates programming in their course content, so it may be why programming stands out more as an experience they are proud of, no matter what year of study. You can also see that the programming experience category is representative of many different themes related to programming, as programming experience can mean being proud of the act of programming, their programming projects produced, and their perception of programming. So there are many more ways that pride can be represented within this category compared to the others, also possibly explaining that result. Something else to notice is that MICA 3-star students appear to be less proud of their math experience and most proud of their SEL skills compared to the other courses. While the theme math experience relates to the students' learning and perception of using the math concepts and using programming to articulate them, the SEL skills themes points to how the courses have developed their personal capabilities, including perseverance, resilience, and agency. We suggest that since there are more future teachers in MICA 3-star versus the other courses, that the students have more of a teacher mindset, where the process and experience of learning is just as important as the outcome, so they may be more reflective of themselves and proud of their development.
Now, when looking at the why or because question, 5 main themes emerge: gaining a skill, change of perception, future use, never programmed before, and dedication, as well as another theme. If we look on the because side, you can also see that the category gaining a skill is the most consistent reason reported by students across all courses. This could potentially be explained because gaining a skill is the most tangible reason to be proud of something, meaning that the students may now see themselves as competent in something they can use outside of the courses. Another interesting result is the future use category. MICA 3-star students consider being able to use what they are proud of in the future the most out of all the courses. A possible reason for this could be that Micah 3-Star also involves a focus on applications in a school math classroom, where Micah 1, 2, and 3 focus on learning in the moment and implications about future use is implicit only.
We note that this study is limited due to the voluntary participation of students and an uneven sample size between courses. Yet these primary results from our exploratory study can now be used by the research team to expand their conceptualization of students' learning experiences. In other words, more time needs to be applied to connecting this study and its findings to the theoretical framework of the larger research project. By doing so, the research team will be able to understand and benefit from knowing what the students are most proud of and because, by using existing theory to support the results in order to answer our research question.